a house. It's going to be 50 feet long, 26 feet wide, and has an 8-foot high ceiling. What is the volume of the interior of this house in cubic meters and in cubic centimeters? Okay, so we're going to have a conversion here. First off, we need to know that volume, V, would be equal to length times width times height if we have a cube type, three-dimensional square type object. So we can go ahead and figure out what the volume is in feet if we want to do it that way, and then convert it over into meters, or we could do a conversion into meters right away and then figure out the length, width, and height in meters to get cubic meters. Either way will work. I will go ahead and just calculate out the volume first in feet. Okay, so the length on this is going to be 50. That's get multiplied by 26, and then that gets multiplied by 8. Okay, plunge that into a calculator here. We get that this is 10,400 cubic feet. Okay, so you would write that like that with the little 3 cubic being above the foot. Okay, now to convert that into meters, we're going to need to do a conversion down below. Okay, so we got to grab our conversion. Okay. The conversion that we have is that we know that 1 meter is equal to 3.281 feet. Okay, so we have cubic feet, which means we're going to have to take 10,400 cubic feet, and we're going to need to multiply it through something to get over into meters. So now I know that 1 meter is equal to 3.281 feet. So to get rid of feet, I want to put feet on the bottom. So I'm going to have 3.281 feet. And I know that is equal to 1 meter. So this is like multiplying it by 1. It's just a conversion factor. But this is feet, and this is feet cubed. So I can either do this 3 times to get feet cubed, or I can cube the entire thing. Okay, and then that will give us cubic meters, and it will give us cubic feet. Okay, so this looks like we would have 10,400 being divided by 3.281 cubed. Okay, if we do that calculation out, or we put it in our calculators here, you'll see that the feet and the feet cubed will cancel, and we'll be just left with a meters cubed. Okay, doing that out, we get 294.5, if you want to do it that way, meters cubed. Okay, close enough on the answer. 294.5 meters cubed. Second part of this question, that was just the volume. Now it wants it to know in cubic centimeters. All right, so now we're in meters cubed, so we need to get into centimeters cubed. Okay, so we'll start with our 294.5. Again, we have meters cubed. Okay, and we'll need to convert into centimeters. So now meters is what I want to put on the bottom. Okay, and we need to ask ourselves how many centimeters are in a meter. Okay, so there should be 100 centimeters in every 1 meter. And this trick again applies that this is cubic meters. Okay, so we need to get rid of this. We'll have to have a cubic meter. Okay, so what that would look like would be 294.5 multiplied by 100 cubed. And then this, of course, the meters now will cancel out, and we'll be left with centimeters cubed. Okay, we plug that into our calculators, and we get a big number. You can write the whole number out if you'd like. However, scientific notation would be a lot better and a little bit cleaner. So when I look at that, I have 2.94, and then I would count over how many spaces that I have. And here, the decimal place has moved 8 positions, so I would put times 10 to the 8th centimeters cubed. Okay. If you are wondering what the answer on that was, I kept everything long in the previous answer so that this would extrapolate out, and my calculator ended up showing this many figures. So this is 1, 2, 3, 4, 5, 6, 7, 8 is how I'm getting the 2.94. And again, sig figs on this one, I'm not too concerned in my class. Other courses might want you to have more sig figs or proper sig figs. In mine, I want you to know how to do the problem, not so wound up on the significant figures. So 2.94 is fine, 2.9 is fine. In this case, I would even accept a 3.0 times